Hello everyone. In this lesson, we will learn how to find the asymptotes. What is an asymptote? Well, an asymptote is a line that the graph of a function approaches but never intersects. Now, we do have three types of asymptotes. A horizontal asymptote, in which the graph of a function might approach that line but will never intersect with. And we do have vertical asymptote, in which again the function will approach that line but will never cross it. And finally, we do have oblique asymptote. So that's a vertical asymptote. That's an oblique asymptote. An oblique asymptote looks like something like that, in which again the function of the graph might approach it but will never cross it. The equation of the horizontal asymptote is actually y equal a number. So I could say this number is 1, so y equal 1. Okay. Vertical asymptote is x, so in this case x equal, let's say, -1. For the oblique asymptote, it should be written in a form y equal mx plus b. Okay. Now let's try to find the asymptotes for this function, 1 over 2x plus 4. Okay, so we are going to start by finding the vertical asymptote. And the vertical asymptotes are vertical lines which correspond to the zeros of the denominator of any rational function. So let's try to find what can make 2x plus 4 equal to 0, x gonna be equal to -2. So if x equal -2, when we substitute it here, we'll get an error. So x equal -2, this is my vertical asymptote. Let me just show you in graphing how this is going to look like. So I can go to -2 here and draw a vertical asymptote. That's -2, right? Now we know that the function is going to approach -2, but will never cross it, okay? Next, we're going to look at the degree of the numerator and the denominator. Well, the degree of the numerator is 0. The degree of the denominator is 1. And we learn if the degree of the numerator equal the degree less than the degree of the denominator, the limit as x approaches positive or negative infinity will equal to 0. Okay, so in this case, we know that the degree of the numerator is less than the degree of the denominator. So we know we are going to end up with a horizontal asymptote at y equals 0. But let's try to calculate it. So limit now divide the numerator and denominator by the leading variable in the denominator. Now the limit, this is going to be 0, 1 over infinity, 0, 0 over 2, which is equal to 0. That's the case if I have positive or negative infinity. Okay, so now the horizontal asymptote will be at y equals 0. So we know that we are going to have a horizontal asymptote here. And the graph of this function will look like something like that. So as x approach -2 from the right side, the function grow to positive infinity. As x approach -2 from the left side, the function is going down to negative infinity. And when the x approaches infinity, the function approaches 0. And same when it goes to negative infinity, the function approach the 0. Okay, now what about this question? Well, again, we are going to try to find the vertical asymptote by making the denominator equal to 0, and that's x equal -1. So we know that at x equal -1, we are going to have a vertical asymptote. Now, we can find the limit as x approach positive infinity for this function. And we can do this really quick. By looking at the degree of the numerator and the degree of the denominator, we will notice that this is 1 and this is 1. They are equal. So when they are equal, by dividing 2x over x, we are going to get 2. So at y equal 2, we do have a horizontal asymptote. But let's show this here by using the limit. By dividing the numerator and denominator by x, we're going to get the limit as x approach infinity, 2 over 1 plus 1 over x. And we know that this is going to be 0, so it's equal to 2 over 1, which is 2. Now, this is the case even if I have negative infinity. We're going to get the same answer. So, at y equal 2, we do have a horizontal asymptote. Okay, if I want to graph this function, it will look like something like that. So, as the function approached the vertical line, from the right side, the function was growing. As it approached the vertical line asymptote from the left side, the function was decreasing to negative infinity. And if I study the behavior of the function as x approaches infinity, the function was approaching this horizontal line, the horizontal asymptote, which is 2, same when x approaches negative infinity. Okay, in this question, we need to find the vertical asymptote, maybe asymptotes, by making the denominator equal to 0. Square both sides, and x squared equal 4, so x will be equal to positive or negative 2. So we do have two vertical asymptotes at x equal 2 and x equal -2. Okay, now let's try to find the horizontal asymptote, the limit as x approach infinity and negative infinity. We'll do each one of them separately. We are going to divide the numerator and denominator by the square root of x squared, which is actually absolute value of x. So this is going to be x over absolute value of x minus 5 over absolute value of x. And in the denominator, it's going to be x squared inside the square root. So now, this is going to be equal to the limit as x approach infinity. Now, if it is approaching infinity, then the absolute value of x will be positive x, which is x over x minus 5 over x. And that's going to be 1 minus 4 over x squared. Now, this is going to be 0 as x approach infinity, which is going to be x over x is 1, 1 over square root of 1, which is 1. Now, what about if we are finding the limit as x approach negative infinity? And we are going to start with the x over absolute value of x again, minus 5 over absolute value of x, again square root of x squared over x squared minus 4 over x squared. Well, if it is approaching negative infinity, then the absolute value will be negative. So it's going to be limit x over negative x minus 5 over negative x, then square root 1 minus 4 over x squared. Now, we know that this is going to be 0, and this is going to be 0. X divided by negative x is -1 over a square root of 1, which is equal -1. That means we do have horizontal asymptotes at y equal positive and -1. So we have two horizontal asymptotes, okay? we do have also two vertical asymptotes. Now this question here, let's try first to find the vertical asymptote, which is x minus 1 equals 0, x equal 1. Now if I want to draw this, I know I'm going to have a vertical asymptote here. And the function will approach this line and will never intersect with. Now let's look at whether we are going to have a horizontal asymptote or an oblique asymptote. Well, by looking at the degree of the numerator and the degree of the denominator, we can decide. If the numerator, the degree is less than the denominator, then we have a horizontal asymptote at y equals 0. If the degree of the numerator is equal to the degree of the denominator, then we will have a horizontal asymptote at y equal the ratio between the leading coefficient in the numerator over the leading coefficient in the denominator. And if the degree of the numerator is greater than the degree of the denominator, then we will have an oblique asymptote, and it will be written as y equal mx plus b. Okay, so now let's try to find the oblique asymptote, because we know it's going to be oblique. In order to find an oblique asymptote, so one more time, no horizontal asymptote. Okay, now for the oblique asymptote, we're going to use long division. So we're going to divide x squared plus 1 divided by x minus 1. Now we do have a missing term here. We replace it by 0. And now we start dividing. X squared divided by x is x, multiplying x squared minus x. And then you subtract. We're going to end up with x plus 1. Now go back and divide again. So we're dividing x divided by x is 1, and then x minus 1, and then subtract. That's the remainder is 2. So at x plus 1, y equal x plus 1, we do have an oblique asymptote. Let's try to draw this line. So maybe the oblique asymptote will come somewhere here, and the function will be here and here. Okay, let's move on to the next question. X cubed plus 1 over x squared, vertical asymptote. X squared equals 0, x equals 0. And again, we don't have a horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. Instead, we have an oblique asymptote. And in order to find it, we need to do a long division. X cubed divided by x squared is x. And again, you can divide by 0, and that's it. You are going to get 0. So y equal x is your oblique asymptote. The graph will look like something like this. X equals 0, it's the y-axis. Y equal x, this line here. And we are going to draw it. So the function will go approach these lines, but never cross them. Okay. Let's move on to the last question here. X cubed minus 27 over x squared minus 9. Well, I can first factor this function. X minus 3, x squared plus 3x plus 9 over x minus 3, x plus 3. We can cross out these two. What is left? Vertical asymptote will be at x plus 3 equals 0, x equal negative 3. Now, by looking here, we will realize that the degree of the numerator is greater than the degree of the denominator, so we know that there is no horizontal asymptote. Instead, we will have an oblique asymptote. In order to find it, we need to do long division. Okay, now by dividing, x squared divided by x is x squared plus 3x (9). That's it. You cannot divide 9 by x plus 3. So you know that the oblique asymptote at y equal x here. Now, if you want to look at the graph of the function, here is x equal -3. And again, that's equal to y equal x, the oblique asymptote. And the function will be here and here. Now, what about this point? Well, at x equal 3, the function was equal to 4.5. So 3, 4.5 will be an open circle if we are trying to graph it. Okay, guys, we are done with the asymptotes. See you next time. Bye.